Hi, welcome to the video for Lab 2 for Math 215. And yeah, I guess just starting off with problem 1. Problem 1 is not so much supposed to be tricky, it's just supposed to be illustrating a principle. All you should do for this problem is copy the code that's given in problem 1, and whatever you get, so when you print my list, you'll get something, you'll get a list and then some values written in it. These won't be the actual values, but it'll be something like this. And if this was my list that I was given, I would say first lm equals 3, since that's my first element. And they just want you to take whatever the first element is and save it under first element. For problem 2, a lot of these have really good examples in the PDFs or in the pages that are shared. And so I would, especially for this one, I would suggest looking at that. Just remember that whenever you're accessing a list, that if I wanted to look at the list at position 0, so the first position, since we always start with 0, I would do that. Just look at the second position, I would do L bracket 1, third position L bracket 2. And if I wanted to look at the ith position, for instance, if I was using I as some different variable, I would say L bracket I. Again, look at the PDF or the pages to really help you understand how to do that sum with a for loop. For problem 3, this is returning a list that's the same as L, except all negative values in L are replaced with a 0. So a really important concept for this one is that whenever you have a return statement in a function, it will take that function. Actually, I think you use original list here. Let me just make sure. Yeah, you'll be using original list. So whenever you have a return statement in a function, once it hits that return statement, it'll actually quit the function and just like totally exit out, take that value, and stop. And so rather than having multiple return statements to return many things, you should want to change your list instead. So for this, problem 3, we want to check if each value is less than 0. So if our value, and remember, whenever we do the range of length like this, our i's will not be our values of the list itself, it will be the indices of those values. So what we could do is say, if L at this specific index, if that value is less than 0, then we do something. And the thing that we'll want to do is not say return 0 or anything like that. We'll just say L at I, meaning we're changing this value, is now going to equal 0. So yeah, rather than returning, we're just changing the value itself. And now you could put an else here that's saying if it's greater than 0, then you would want to change it to itself, but that doesn't really do anything. That would just be saying L bracket I equals L bracket I. And that doesn't really do anything in the code. So we can actually ignore that else statement because we can leave it alone. And then at the very end, we'll want to return our changed list. So we'll return original list. And I messed up. Be sure to change both of those to original list. And I just abbreviated there, but do the whole thing. Now for problem 4, this is pretty self-explanatory. Just remember that for exponents, e to the something, use np.exp. And then for your log, you'll do np.log. And all of these should be written in there just to remind you that these are what you're going to use. And another helpful problem for problem 4, and I guess for problem 5 as well, whenever you have something that you want to set equal to a variable for the greater, so like myvar equals something, rather than writing out the decimal, so like 34 point something, I would save it instead as the entire function you use to get that. So myvar instead would equal like np.exp and then whatever you're gonna have. And so don't save it as the value, save it as the function. And that's especially true for problem 5. I won't say much about problem 5 except remember that this is going to be your dot product function. Whenever you see the dots, you use the dot product. And you'll save that whole thing as myvectvar. And so rather than saving it as like a list of 2.4 and something else, I would save it as the function used to get that. For problem 6, this one is definitely a little bit tricky. And so I'll hopefully help you guys step through it. And we'll be using original matrix. So remember that a matrix is going to be a list of lists. I like to think of it as a list of lists. So you have a list whose elements are lists themselves. And I'm just going to abbreviate. This is original matrix, but be sure to write out the entire thing whenever you're doing it. Now I'll introduce something really quick right here. That shouldn't be M, that should be original matrix. Since all of the entries are lists, if we want to say original matrix at 0, for instance, this will look at the first list in our matrix, or the first row in our matrix. And I will look at like the ith row in our matrix, or the ith list. And so what this statement does is it looks at every list and says, oh, I'm going to set every list equal to the first list, or the first row. And that's actually all you need to do. You don't need to do double for loops or nested for loops for this one at all, because you only need to look at the lists themselves. You don't need to look at the entries within those lists. And then you'll want to return your changed matrix, so return O_M, or original matrix, as you'll write it out. So that hopefully should help with problem 6. Again, you don't need to do 2 for loops. You can just do 1 for loop, and this should cover all of the bases. Now problem 7, again, problem 7 has a really great example in the pages that you've been provided. But I'll just remind you that to sum, you want to do like sum equals sum plus, and then whatever you're going to use for this function. And you'll be using M for your matrix. And to access a 2-dimensional matrix, and so yeah, we'll be saying we have 2 dimensions to this matrix. The way I would write it is, assuming you're using I and j for your bounds, you would say this, meaning I have my matrix and I'm going to look at the ith row and the jth thing in that row. So if we use the matrix M, I'm trying to find a good example of M. I'll just say, if this is our matrix, and I was looking, say this is M1, 1. This would look at the second row in M, so this row, and then it would look at the second thing in that row, so that 5. Whereas if this was like 2, 2, it would look at the third row and the third thing in that row. And look at the example to see how to set up the double for loops. Now for problem 8 and 9, these are definitely tricky ones. And so we'll be saving this first one as long list. And list comprehension is definitely tricky. It definitely takes some getting used to. But first, we definitely see a pattern in this list that we're supposed to see. We have 0.5 to the something, where that number is incrementing. And so, kind of first, what I think is, oh, that number is incrementing, so we'll want to set up a for loop, because it's going to test lots of certain values that are all the same after a certain pattern. So I'd say for I in range, now let's see, it starts at 1, so we want to specify that, and it goes up, it goes to 100, so it goes up until 101. So if that's our for loop, then we can actually just stick that into our list comprehension. This will be your long list. Long list is equal to this list, and we can actually just stick that for statement right in our for loop. 101, or right in our list. Now what do we want to do for each of these i's? We want to do 0.5 to this I, because this I will be 1, then 2, then 3, then 4. And so right here is where we'll write what we want to do with that iterator. So we'll say 0.5, and then remember to use asterisk asterisk for powers. 0.5 asterisk asterisk I. And so that says whatever I'm going to do my for loop for, and then what I'm actually going to put in the list. So that should help for problem 8. And then for problem 9, definitely the trickiest one. Again, I would start by setting up for loops just to kind of see how it would work. So we know that our first for loop, I'll set up 2. That's just, you'll want 2 for this question. And if I have 2, if you think about it, then this one, let's say it is running a variable 1 right now. It'll run 1 for all of this code, and then it will switch to the next number. Let's say it's 2. But while it's running 1, this will run whatever code it has. Let's say it does 10, 11, and 12. So this will do 110, 111, 112, and then it will switch to 210, 211, 212. That's how the order works. And so if our secondary for loop is the one that's switching all the time, and we look at our problem 9, then we see that the one that switches more often is going to be our 1, 2, 3. So I'd say for J, and just because it's the second one in and we usually use J, for J in range 1 to 4, because we want to do 1, 2, and 3. And this will do for I in range. And what's the other one that repeats but doesn't repeat as often? It's going to start at 1 and it's going to end at 99, so we want to say 1 to 100. And so those will be your 2 for loops. Now the question is, how do we translate those to our list comprehension? Well, we'll say our very long list over here, I'm just going to call it very, but call it very long list, is going to be the list. Again, we're going to have something here, but we'll figure it out afterwards. What we want to do is say, whenever we have 2 loops like this and you're not sure which one to put first, we're always going to put our higher one first. So for I in range 1 to 100, and then we can actually just put another for loop directly after that. And I might run out of room. I'm not sure if you guys can see that. So you'll put your outside for loop first and then your inside for loop. And now if we look at exactly what we want 1, 2, 3, which is going to be our J, to the 1, 2, 3, 4, 5. And so that would be J to the I. And so that's actually what we'll write down right here for our list. And so that seems a little weird because I is first here, but it's second here. But that's actually how we'll set it up for this problem. So yeah, that's problem 9. That hopefully should get you through the rest of the lab. And if you have any questions, you could come to any of the TA's office hours or email any of us. Best of luck on the lab.